Okay, so today we're going to be talking about VPNs. So we're getting to the interesting part now. What have we done so far? So far we've really just been learning about MPLS. So we've set up some label switch paths. We've discovered that we can use signaling protocols, RSVP, LVP, to set up our label switch paths. We have discovered that we can put in place traffic protection, things like fast reroute and link protection to make our VPN or our label switch paths more resilient. Okay, so today we're going to get into VPNs. So let's take a look at that. First of all, we're just going to do a review generally of VPNs. So it's really just an overview of the concept of VPNs. There. Okay, so we're going to look at the concept of VPNs, describe the differences between provider provisioned VPNs and customer provisioned VPNs, and look at also layer 2 and layer 3 VPNs, and we'll get into talking about the types of provider provisioned or MPLS VPNs that are supported in Junos. So let's look at the concept of the virtual private networks. What are they? This is stuff you already know. It's basically a private network which goes over a shared infrastructure or a public infrastructure. So it's virtual as opposed to physical. So in other words, we don't have a dedicated physical connection between 2 points. We have a virtual connection between 2 points. I mean, once upon a time, you would have a physical connection between 2 points. There were days when VPNs weren't available. So what you would do is you would go to your telecommunications provider and you would get a thing called a leased line. And a leased line is a physical connection that you would then use to connect your 2 sites. I remember years ago using those leased lines in various situations that I was involved in. We had a leased line. Well, VPN is not a physical connection. There is a physical connection, but you don't own that physical connection all to yourself. You share the physical connection with lots of other people, but your connection is a virtual connection. It's private, and that it has separate addressing and routing that is, well, your addressing and your routing for your network. And of course, it's a network. So constraints, it's all about providing restricted connectivity. So the only parties that are involved in this connectivity are the 2 endpoints that are requiring this connectivity. So ultimately, it becomes the customer sites that are involved in this connectivity and no one else. So we're using IP infrastructure. We can share our VPN with internet services. So really, what we're seeing is that once upon a time, these services were provided by a service provider or a telecommunications carrier using ATM or frame relay. Now those same services are provided using MPLS. So what are the benefits of, I guess, MPLS to the customer? Lower operational expenses, single network connectivity. And what does the provider get out of it? Well, they get to utilize their existing infrastructure and being able to sell additional services using their additional infrastructure. Okay, so let's take a look at classification. We've got CPE VPNs, or customer premises equipment VPNs. What's a couple of examples of those? So there is L2TP and PPTP. Then we've got IPsec. Okay, so let's just talk about IPsec for a minute. That's something we're quite familiar with. How does IPsec work? How do we set up an IPsec VPN? What happens? What are the bits and components, I guess, that are involved in setting this up? We've got, well, first of all, we've got a couple of sites, one or more sites that you need a connectivity between, one or more sites. Okay, now, what is the equipment that's involved in setting that up? Well, you've got your gateways in each site, haven't you? So on your gateway devices for each site, you configure an IPsec VPN, which then you connect from one gateway to another gateway. It's typically how it works. And by connecting those two gateways with an IPsec VPN, what you've effectively done is provided connectivity between the two sites. Okay, now, can I ask you a question? Is the Internet service provider involved in that process? So here's you in one site, configuring your gateway to connect to a VPN, or use an IPsec connection with your other gateway in your other site. So you are establishing a connection between the two gateways. So you configure one gateway to connect to the opposite gateway, and you go over to the opposite gateway, you configure that one to connect back to your first gateway. So here you have a two-way connection in IPsec. Is the service provider, your internet service provider, are they involved in that process? Are they involved? Do they need to know? Do you ring them up and say, hey guys, we're setting up a VPN? Are they involved? No, they are not involved. They don't even need to know. You don't need to make a phone call. You don't need to tell them anything. You just go ahead and do it. So as far as they are concerned, it's just normal internet traffic that's coming out of the site. They don't know that it's VPN. Okay. So the service provider is not involved in that at all. Then there's L2TP or PPTP, and what is that all about? Well, that's about you sitting down there on your laptop and having a remote connection into a server inside your corporate network. So it's usually device-to-device type connectivity. How that works. Okay. And again, your service provider is not involved in that process at all. There are provider provision VPNs, and there's some RFCs that go around describing how they work. Here's one here: BGP, MPLS-based VPNs. We also have layer 2 VPNs, and these things called virtual private LAN services, and there's other things which are kind of, I guess, redeveloped and have sort of come about in addition to those services as well. So here's a question. Obviously, if you go to your provider, you say to the provider, I want you to set up a VPN for me. They're going to charge you something for that, aren't they? They're not going to do that for free. But no worries, here you go, here's a VPN. No, they're going to say they will charge you. They'll probably charge you to set it up. They'll probably charge you to maintain it. Okay, so there will be a setup fee, and there will be a monthly, usually a monthly subscription for them to maintain and provide that VPN for you. Now, here's a question. If you can, by yourself, just using your own equipment, go ahead and set up an IPsec VPN, why then would you pay money to have a service provider set up a VPN for you? Why would you do that? Why would you do that? Does it make sense that you would do that? Is there any reasons why you would do that? Well, yes, there are reasons why you do that. And the main reason is this. When you set up your own IPsec VPN, the VPN traffic that goes from your site to your service provider is treated like all other internet traffic, in that it is best effort delivery. So it is subject to all of the other variables that impact any other network traffic that happens to be going across that provider's network or any network in between your two sites. If there's congestion, it can get dropped just like any other traffic can get dropped. And usually, at some point, it will get dropped. So what you will find with an IPsec VPN is that it will work most of the time. Okay? It will work most of the time, depending on how good your service provider is at both ends, for that matter, of your connections. Will kind of determine how often it works or what the uptime is. Say that. What is the uptime of your VPN? It'll work most of the time. It may work 90% of the time. Okay. So, with a service provider provision VPN, however, you can have your VPN traffic treated very differently to all other traffic. You can have your VPN traffic given a higher priority to other traffic. You can have circumstances, as we've seen, with different types of protection mechanisms within MPLS. You can have your VPN traffic protected by things like fast reroute or link protection mechanisms. You can use signaling protocols that can quickly signal alternative paths if a particular path becomes unavailable. We can have things like a bandwidth allocation. Can't we? We can set up a router switch path with a bandwidth requirement. We can say we will put constraints in place that says we must have a certain amount of bandwidth. You can set constraints in place that you can actually set up prioritization of traffic across a VPN. So you can give traffic a particular priority. So we have ability to put in place a far more reliable VPN, okay, a wider provision VPN than we do with just IPsec. And that is the reason why you would pay a provider to do that. When connectivity is essential, and that is kind of like mission critical, must have, really looking for really 100% uptime on this network, you would go for that kind of, you would actually pay for a service provider to put that connectivity in place for you. The other reason that you may want to do that is if you wanted, if the organisation, the customer, wanted to offload the routing functionality to someone else. So in other words, you've got a customer, they're not really in the business of routing, they're in the business of doing something completely different. Maybe they're a government department, maybe they're a local council, maybe they are a corporation with multiple branches. They're in the business of doing whatever their business is. Their business is not IT. Their business is not routing. So they can take their requirements and offload that or outsource that to a service provider whose business is routing, and then allow someone else to provide that connectivity. So they don't have to then have the staff to take care of that issue. So that is a fairly attractive proposition to many organisations. Okay, so we have got customer provision VPNs and provider provision VPNs of different types. Okay, so here we are. This is our review of our customer provision VPNs here. This is our layer 2 tunneling protocol, or point-to-point tunneling protocol. You can put IPsec over these, by the way, just for extra security. So we've got a device which sort of has goes through a sort of a dial access server, and goes across a tunnel and connects to another server. So this is really kind of device-to-device connectivity. Part of, sort of bundled into bundled into Windows Server and also to Windows Client. So you can set up one of these connections from a Windows 10 desktop into a Windows Server. Okay. Then there's IPsec, which we know a fair bit about, and as we know, great security, lots of access control, authentication, all kinds of protection built into it, encryption, key management, etc. It's all built into IPsec. So great protocol, works extremely well. And there we are with Site 1 and Site 2, and we've got our CPE gateways sitting in each site, and there we go. We've provisioned up an IPsec VPN across the public internet. Really, we're just configuring it up between our two devices, and IPsec will take care of that tunnel and make sure that our traffic gets from one end to the other safely and securely. So that's those two. Then there's provider provision VPNs. There are both layer 3 and layer 2. Layer 3 is actually the most common one, because with layer 3 the customer gets totally outsourced all their routing requirements to their ISP. So what they're saying is, we don't want to take care of our own connectivity, you take care of it. And what typically happens is you have some kind of, we have a service level agreement which says this is the level of service that we require from you, or often the provider comes back and says, hey, this is the level of service that we're going to offer you with our layer 3 VPN products, and this is what we're going to charge you for that. That's really how it works. So sometimes these things are kind of negotiated on a per customer basis as well. So that's layer 3. Then there's layer 2, where the connectivity between the sites is just kind of like a rapid switch. So really, the routing is still handled by the customer, but the service provider just provides the connectivity between the sites. Okay, so layer 3 VPN. So that's what we're going to do today. We're going to do these layer 3 VPNs. Application, outsource the VPN. The router maintains VPN-specific forwarding tables for each of its directly connected VPNs. So here we have these things called PE, Provider Edge, and CE, Customer Edge routers. We've looked at those before when we were talking about MPLS generally, but now when we're talking about VPNs, it is the Provider Edge routers that maintains customer-specific VPN information. So we've got different customers, we've got customer yellow and customer red there, and they've got different sites that they want connectivity between. So a service provider can provide VPN connectivity for multiple customers at the same time and keep all of their virtual networks separate from other customers. Okay, we're going to get into the detail of how this works. We're going to do some labs on this. So the main points are that the PE router maintains the VPN-specific forwarding tables for each of its directly connected VPNs. What does that mean? That means that the routes to the customer's network are maintained by the service provider. So the customer's network are using private address ranges. So within the service provider's routing tables, and in specific this VRF table, are the private routes for its customer networks. Okay, private network address ranges are sitting in those tables, and they provide routing information to get traffic between the customer sites, so from one site to another site of that particular customer. Okay, so the VPN routes are distributed using a protocol called MPBGP. We're going to configure that and set that up today. We use a thing called extended communities to manage the way that routes are imported and exported into and from these VRF tables. Let's look at that today. And the VPN traffic is forwarded across the provider's backbone using MPLS. So the actual traffic itself is going via a label switch path. The interesting thing there is that the IP addresses on the traffic are private addresses. Okay, private addresses going across a service provider's public network. How is that happening? Because we're not forwarding based on the IP addresses, we're forwarding based on labels. Alright, so we can do forwarding across the provider's network based on labels and not private addresses. So the private addresses are hidden inside the MPLS packets. Okay. So layer 3, provider provision VPNs. We're going to be using either LVP or RSVP to set up the PE to PE label switch paths. So that's between the across the provider's network. So the MPLS label switch paths are going across the provider's network. So they're not going into the customer's network. They're the ones that these paths are going across the provider's core network. And then the routing readability for the VPNs is all handled by the routes that are being transferred between these virtual routing and forwarding tables. We have labels for the customer sites, tunneled in our label switch paths. We'll set this up today, have a look at it. And we have constrained connectivity by the route filtering. So what that means is that we are able to make sure that the traffic for a particular customer stays within that customer's VPN and it doesn't get out or doesn't go to the wrong places. Those routes are not propagated into the wrong routing table, so that the customer's traffic stays the customer's traffic. Okay, so we have these virtual router functions. Virtual router maintains VPN specific forwarding tables. We're going to set these up today. The PE router participates in private network routing. So there we are. We have got private address ranges that are not allowed on public internet, but there they are, sitting in the service provider's routing tables, routing traffic, which is private address traffic across the provider's network. Okay, as I said, it's hidden in a label switch path. So the forwarding is done based on a label, not on an IP address. Okay, so we can apply IPsec to this traffic if you want to. You can actually put IPsec across, or apply IPsec to a label switch path to encrypt the traffic and provide all the benefits of IPsec. Use it as GRE as well, so different possibilities. Okay, so what are the advantages of these layer 3 VPNs? For the subscriber, it's really the ability to outsource and offload the routing function to a specialist. And there are organisations that find that very appealing. In our region right here, our local council does that. I remember there was a time where they employed lots and lots of people to take care of that function, and they decided this is way too expensive. So what they did is they got rid of those people and they simply outsourced to an internet service provider, and who of course specialises in routing. That's what internet service providers do. they outsource that whole functionality, and now that is provided by a layer 3 MPLS VPN. All those sites together. So for the provider, the VPN specific information is not maintained on all backbone routers. What does that means that for the provider, this is a very scalable solution in that it's only the edge routers that have to participate in the VPN. Not all the routers in the whole network have to participate in the VPN. So for the provider, there's only certain routers, which are the PE routers, that provide edge routers that participate in this VPN, which means that it is less administrative work to set up the VPN and to make changes to the VPN. A customer comes along and says, I want to add an extra site. I've got a new site, I want to add that into the VPN. Well, you don't have to go and reconfigure all of your routers to provision that extra site. You only really have to set up one or configure one route to provision that extra site. And of course, the provider can make some additional money by providing those services. Okay, so the layer 3 VPNs are the ones that are far more common than any other type, than the layer 2 types. Okay, so the outsourcing moves that burden across to the provider. For customers that don't want to outsource that routing architecture, the option for them is to do a layer 2 VPN. So that's where layer 2 VPNs come in. Let's take a look at that. So the layer 2 VPNs, there's quite a few of them that have been around over the time. We have this CCC, BGP layer 2. There's quite a few different variants of it. And that's not all. There are newer ones than that as well. If you actually go onto the learning portal, there are some learning bytes on even newer VPNs, newer layer 2 VPNs than those. So the first one is this cross-circuit connect, provides a foundation for an MPLS-based layer 2 VPN. So everything is kind of got built on this concept here. Many different types of connectivity is supported between the provider edge and the customer edge, frame relay, VLANs, etc. The reason that frame relay and all that is there is because people had made an investment in that, so you couldn't just throw it out and say, okay, I'm not supporting that anymore. You kind of had to support that. But there are many other types of connectivity that are also supported there. Service provider maintains label switch path between their PE routers and one label switch path per BCB server. So for every virtual circuit, in other words, a connection between a site or between two sites, we have a separate label switch path. Ingress PE, which maps each outbound PVC or permanent virtual circuit to a dedicated label switch path, and the egress PE maps the incoming label switch path to an outbound permanent virtual circuit PVC. Okay, so the customer edge will route the VPN traffic based on subnets and PVC mapping. So what we're really achieving here is kind of a layer 2 connectivity. Some drawbacks to this. This really has been superseded. This cross-circuit connect has been superseded by other technologies. It really wasn't all that scalable, really a high administrative burden. BGP layer 2 VPNs are more scalable. Data and control planes. Data plane uses label stacking, consolidates multiple DLCIs into a single path, PVCs or VLANs over a single LSP, and provisions of BGP for auto configuration. So some advantages there. There are other types of layer 2 VPNs which kind of leverage off the original CCC. There's just improvements on that. I don't want to kind of spend a lot of time delving into these, but just kind of have a look at what they are. Virtual private LAN service really makes the whole provider network look like a great big switch. And so basically the routing is provided by the customer and the connectivity is provided by the service provider. I don't know the best way to describe that. So what are the advantages of these to the subscriber? They can outsource their circuits, maintain control of their own routing, and they can use any layer 3 protocol. And to the provider, again, it's just an extra service that they get to provide, and they can leverage their own core network capabilities to provide that particular service. That's the main points there. What are the issues with this type of service? Well, we have to have, there are some constraints around the circuit type. For each VPN, they have to be the same at each end. It does remove a provider revenue opportunity in that they don't get to manage your routing, so you're still managing your own routing, so they can't charge you for that. And the customer's got to have routing expertise. So, a bit of an overview, just kind of a snapshot of, you know, different types of VPNs that have been around. These have been around for quite a long time, where service providers have been providing different types of VPN services. So, the most commonly asked for VPN is a layer 3 VPN, because really often the objective of the customer is to just outsource that particular routing function to a specialist, which is of course the internet service provider or carrier. Okay, so basically that's really what we're going to look at there. What is a virtual private network? Well, we kind of know what that is. Private network across a private connection across a public network or a shared access network. The difference between this CPE VPN and a provider provisioned VPN is the fact that the provider is involved in the process with the provider provisioned VPN. And the difference between the layer 2 and the layer 3 is that with the layer 3 the routing is handled totally by the provider, whereas with the layer 2 the routing is handled by the customer, and the provider is just providing the connectivity, the circuits between the customer sites. Alright, so just a bit of an overview of VPNs. Let's get into the specifics of layer 3 VPNs. And let's just get that sorted here. That's what we want to be, layer 3 VPNs. Let's get that out of the way. That's better. Alright. Alright, so we're going to take a look at layer 3 VPNs, and kind of this is where it gets interesting. We're going to get a head around how does this work? How do these layer 3 VPNs work? It's going to take us a bit of time to get through all of this. So before we kick off, why don't we take a short break? And when we come back, we'll just take a short 10-minute break. When we come back, we'll get stuck into how these layer 3 VPNs work. So let's come back in 10 minutes.